Hey guys, hi, welcome back. So in the previous video, we have seen the introduction to the moving charges. In this video, we will see the Biot-Savart law. So what you will see is that the Biot-Savart law, it gives us the direction of the direction magnitude of magnetic field. Okay, using the Biot-Savart law, we will calculate the magnetic field produced due to a current carrying conductor. So to understand this, what we will do is suppose if you are having an infinite wire, this is the infinite wire. Okay, and if I current flows through it. And if you are taking any point P, okay, which is at a distance R, okay, it is at a distance R from the wire, and R is the position vector. And this vector R makes an angle theta with this wire, okay. Now you see what the Biot-Savart law says is that the magnitude of magnetic field, it is directly proportional to the current element. What is current element? This small length. This entire length is infinite. This small length is called dl. And current will flow I through this length. Okay, so IDL is said to be as the current element. So the magnitude of magnetic field, it is firstly directly proportional to the current element. Secondly, what the law says that it is directly proportional to the sine of the angle between the position vector and the current element. This current element and this position vector has angle theta. So it will be directly proportional to sine theta. And thirdly, it says is that it is inversely proportional to the position vector, means the distance between the wire or the conductor and the point where you need to calculate the magnetic field. So it is 1 by r square. So here when you will combine all these three equations, what you will write, dB is proportional to IDL sine theta by r square. Magnetic field is directly proportional to current element sine of the angle theta, which is between position vector and the current element, and inversely proportional to the square of the distance between the conductor and the point P. Okay. So in mathematics, we know whenever we are removing the proportionality sign, we put the equal and a constant k first. So it is IDL sine theta, okay, by r square, which can be further written as B is equals to, here k is your mu naught by 4 pi, and this is your IDL sine theta by r square. So this is your Biot-Savart's law. Here if you see mu naught is what? Permeability. It is your permeability of free space. All right. And you can write mu naught by 4 pi. It is equals to 10 to the power minus 7. And you can write from here mu naught is equals to what? 4 pi into 10 to the power minus 7. Clear? So this is about it. Now you will have to remember direction of magnetic field is perpendicular. We already saw that current and magnetic field are perpendicular. So in this case also current and magnetic field is perpendicular. Clear? There is no doubt in this case. Next, you can calculate here. The unit also you can find, okay? You can write the unit of mu naught also in this case. How you can write the unit of mu naught? You can write, because you see here, you can write mu naught is equals to dB, right? dB into 4 pi r square, right? It is dB into 4 pi r square divided by IDL sine theta. If you see here, sine theta is having no unit. 4 pi has no unit. So the unit is what? Tesla. For r square, it is meter square. Current is ampere. Length, it is meter. So this m and m gets cancelled. It is Tesla meter per ampere. This is the unit of mu naught. Clear? So this is how you can see the unit of mu naught. Next, let us see Biot-Savart law in vector form. So first of all, what we got, the Biot-Savart law. What is the magnetic field's magnitude? dB is equals to mu naught by 4 pi IDL sine theta by r square. So we will put a unit vector here. This is how we can convert a quantity into its vector form. So we know unit vector is equals to what? The vector divided by its magnitude. So directly we will just put the value here. dB is equals to mu naught by 4 pi IDL sine theta by r square, the vector r divided by r. So what you can write here, dB is equals to mu naught by 4 pi. This is your IDL sine theta, r square and r will be multiplied, you will get r cube r. So here further, if you see, if you have studied about vector, you know that dl and r are vector, right? So dl r sine theta, it can be written as, in this case, it can be written as dl cross r, right? You can write it in this way because you know cross product of two vectors is what? AB sine theta. So the same thing we have done, dl cross r is your dl r sine theta. Okay, just a second. Clear? So this is the vector form. And from you can, here you can write dB is perpendicular to dl. You know vector well. And dB is perpendicular to r. And also we have already discussed that magnetic field is always what? Perpendicular to the length. We can take it because if you are having a straight current carrying wire, we know the magnetic field is in what? Concentric circles. This is your magnetic field. This is your what? dl. So it is always what? 90 degree. And r, it's the position vector. If you see here, this way if you draw, you know this is like the radius, right? So then here also it is what? Perpendicular. Simple. So the magnitude of magnetic field, it is always perpendicular to the elementary length and the position vector. So this is about the Biot-Savart's law. We need to remember both the form, okay? General form and vector form both. So that's all in this video. Thank you so much. In the next video, we will discuss the application. Have a good day.